Hello everyone. Today we are going to see linear search as an instance of a program for arrays, loops and conditions being used together. As an example of using all these three things together, I will be using an example called linear search. We'll first evolve actually the algorithm for linear search, and then we'll try to implement that algorithm through a program. So what we're going to do is linear search. Suppose there is an array that needs to be sorted linearly. These are the array elements. These are the indexes, and we'll put some random values which we'll try to sort. Suppose the values are 13, 17, 19, 23, 27, 31, 37, 41, 43, 47. So this is a linearly scattered, this is a randomly scattered array, and we'll sort this array using linear search. In linear search, what happens is, it's a linear search. You're looking for linear search, right? Or sort. It's a linear search. So this is an array which is randomly scattered, and in this array we have to search for a key element. Suppose the key element that we have to find here is, suppose, 17. So can you tell me 17 is present in this array or not? If present, then it is present at which location? So you say that 17 is present and 17 is at location 7. Can you tell me how did you do that? Exactly. What did you do was you compared 17 with each and every element one by one, one by one, one by n1. So you will compare 17 with how many values? Maximum? No, you will try to compare all the 0 to 9 values. So there will be a loop that will go from 0 to 9, and for in every iteration, what will you do is you will compare the key element with every element of the array, which is array of I, where I goes from 0 to 9, and I will increment in every iteration, isn't it? So wherever the key is found to be equal to array of I, you will say that the element is found at location I. You will say element found at location I, isn't it? And if suppose, this is the loop that will go on till the 0 to 9 means 10 iterations. Wherever the element is found at a given location, you will print the location I, and then after that you will do return, say I, and your function is over. But if in case you went throughout the loop 0 to 9 and your element was never found, in that case the loop will be over and you will come out of loop, you will come here. If in case you end up at this position, that means the element was never found and you was never able to print element found at location I, and you were never able to return I, and you were never able to finish the program from here. In that case, what you would do is you will come out of the loop here and you will say element not found. Okay, so this is how you will implement linear search. Okay, now I will try to implement linear search using the same algorithm, in which what we'll do, first we will get the array, declare the array, store values in the array, then display the unsorted array. After that, sort the array according to the algorithm given here, and then display the sorted array. Okay, so let's try to implement this program here. Let me open your directory. In your directory, we'll implement your program here called linear search. Here it is. First, you have to get the array. Okay, int main always returns 0, print getting the array elements, enter array elements, and you will get all the array elements in the loop, as you know that I is equal to 0 to I less than size n I plus plus. Now what is this size n? Size n is a macro with argument, and this macro will be defined like this: hash define size macro with argument, and the macro will have macro expansion in which you'll have n. Okay, and this macro will be called from here. Okay, initially let's say that the size is constant. You make it 10. Size is, say, constant 10. So wherever you use size, it is replaced by 10. You declare the array int array of size. Size means size number of elements. Okay. Now you scanf and store the values in the array. Address of array ith location. I is a loop variable, declare I also. Now your array is filled with values. Now you will yy print p for paste. You will enter the unsorted input array. No need to display this. You enter the key value yy p. Enter key element that you want to search yy p, yanked, copied and pasted. So this is your key element key. Declare key variable. So you have the key also. Now you will start implementing this algorithm which you have learned. Okay, you see right at the beginning you have a loop going for I is equal to 0 to I less than equal to size, that is 9. So you will start the loop again. That will go, I want to copy this line, escape yy, and I want to paste it here p. So you have this loop running here. Inside this loop you will implement your algorithm. You will implement your algorithm here. The algorithm says you have to compare key is equal to array of I. If your key element is equal to array of I, that means the element is found. And if the element is found, you will give the statement that the element is found. You will say key element, print the element, %d found at location %d. So key element is key found at location I, and then after that you will give return statement that the program is over. But if in case you end up here after the loop, then you'll say key element not found. That's it. Let us try to run it. This is your program. Linear search. Compile it. Compiled successfully, is it? Yes. Then run it. Enter key elements. Randomly scattered elements, and we want to find 33. Well, it says key element 33 found at location 7. Did you see that? And if we enter elements like this, and you try to find out 34, it says key element not found. That's the implementation. What is in here that you're not able to understand? Well, this was the very first attempt where you tried to convert your evolve the algorithm, and you tried to convert the algorithm into program. That is what you need to do when you learn C programming with me. I hope you are able to understand this. Say yes or no. Very nice. Okay. Now I'll go ahead and try to implement